morning to all. Myself Shasana, and today we are going to learn about decimals. So now let's start our new topic in an interesting way. So I have a question for you. Why is there one more day in the leap year? So now let's talk about that question. So as we all know that after 4 years there is one leap year which comes after 4 years. Now in the leap year there is 366 days and in the normal year there is only 365 days. So why is there one more day, one extra day in the leap year? So for understanding this, let's understand the decimals first, and then we will talk about why are there 366 days in a leap year. So now let's start understanding the decimals first. So as we all know that the math could be represented mostly in the 4 languages: numbers, diagrams, variables and words. So now let's represent half again. So we had learned what is the spelling of the half, and I think you know that already. Now half could be represented in the word something like this, and then in the variables, as we all know, the half could be represented as any alphabet and upon 2. You can also select any alphabet. It could be A, it could be B, it could be anyone which you like. So now then we have the diagrams, and in the diagram the half could be represented like this. The shaded region in this circle. Then here it comes the number part. Now in the numbers there are 2 ways to represent the half. So the first way, we had already talked about that in my fractions video. You can go through that by clicking on the I button at the corner. So in the fractions we can represent the half as 1 upon 2. What about the decimals? Now there is the second way from which we can represent the half, and that is the decimal by the help of the decimals. Now in the decimals, half is represented as 0.5. So half could be represented as 1 upon 2 or 0.5. Now let's understand why is this 1 upon 2 equal to the 0.5. Does it look same? No, not. So let's see how does the 0.5 is same as 1 upon 2. Why does these both carries the same value? Now let's have a look to that. So if we will take the 0.5, do you know that the decimals are in every number? For example, if we will take a whole number like 2, so we can thought of it as 2.0 and infinite number of zeros are there after the decimal point. So as the 0 doesn't carry any value after the decimal point, because of that we neglect the 0 and the decimal point, and that's why we write it as 2. So that means 2.000 is equivalent to 2. We can have 2.000 is equal to 2, 2.00000 is equal to 2. All of them are equivalent to 2. That's because the 0 after the decimal point doesn't carry any value. Now let's see in this. So now what we are going to do here is to write it as the fraction. How you will do that? Very simple. Any number divided by 1 is that number itself, and the fraction is just the division problem. Now how you will represent this? Something like this, right? Now as we all know that this 1 could be also thought of 1, 0.00 and infinite number of zeros. Now, let's see. So, what we are going to do is to shift this decimal point towards left. Here. Yes, sorry, towards right. So now we are going to shift the decimal point towards right. So now let's shift it out. So if we will do that, we will get the decimal point after the 5. So that becomes like this, right? Now we can thought of the 0 after the decimal point. Now here, when we do the something to the upper, to the numerator, then we have to do that same thing in the denominator also, so that the value of the number doesn't change. Now, what we had done is that we had shifted the decimal point towards right. One step only. So now let's do it to the denominator. So if we will shift that out, so we will get 10.0. So now 0 could be neglected and it could be written as 5 upon 10. And as we know that we can simplify it as 1 upon 2. So what we had got now? 1 upon 2 and 1 upon 2 is half. So that means that 0.5 is equal to 1 upon 2. So I think that you are clear with this. So the fractions are the decimals and the decimals are the fraction. Something like this. That's how the relation works like this. Now, I think that the relation between the fractions and the decimals is clear to you. Now, let's see one more thing. So, we had talked about 1 upon 2. So, we will take the circle and divide it in this like. So, we had got 2 parts, 1 upon 2. So, and we had learned that this shaded part could be as 1 upon 2 could be represented as 1 upon 2 or 0.5. They both carries the same value. And now, if we will divide this circle into 4 parts like this. Now let's do it. So we will take the same circle and divide it into 4 parts. 4 equal parts. So each part will be the half of half. Now what do you mean by half of half? Let's have a look. So if we will have one whole circle and if we will divide it into the half, we get this much. This much portion. Now, what is the half of half? This is the half. Now half of half. That means this is our half. Now just divide it into again 2 parts. So that means we will do like this and we will get 4 parts. So that means each part will represent 1 upon 4. So now I think this much is clear to you. So each part will represent each part can be represented as 1 upon 4. Now do you know that 1 upon 4 is equal to 0.25. Now let's see how is that. So now let's see that again here, and as we had done something like this with the half, with the 0.5, let's do it with this number also. Now what we have to do is to make this 25 as 25. Because we have to get the whole number. So for that, let's shift the decimal point. How many places I have to shift in which direction? I have to shift 2 places to the right direction. So that means 1, 2. Now our point is here. Now let's imagine 0 over here and it is something like this. Now, as you can see at the denominator, if we had shifted the decimal point towards right 2 steps, we have to do the same to the denominator. And because of that, what we get here, when we shift it, we get 100 at the bottom. Now this 0 to 0 and 25.0 upon 100.0, we can also write it as 25 upon 100. Now I think this much is clear to you. As you can see right now that 25 and 100 can be divided by the same number, which is 25. Yes, they have the common factor. So 25 into 1 and 25 into 4. What's our answer? 1 upon 4. So that means, that proves that 0.25 is equal to 1 upon 4. So I think it is also clear to you. And now let's return to our first question. Why are there 366 days in a leap year? Now let's have a look to that question. Now as we all know that before the calendar was invented, the time was a little, time was not, the people couldn't calculate the accurate days in a year. Let's take the example of the Egyptians. Now when the Egyptians saw the constellations, they wondered about that, and then they observed that very carefully, and then they get to know that the constellations shift a little after every 365 days. Now because of that, they came to believe that there are 365 days in a year. Now at that time, the calendar was unknown and the accuracy of the time was not there. So now at this time, at this moment, we have technology, and because of that, we came to know that exactly there are 365.25 days in a year. So number of days in a year, so that is 365.25 days. So it is 365.25 days. Now, if there are this much, so as we all know that after the 4 year, what will happen is that if we will plus this 0.25 4 times, 0.25 is equal to 1/4. Yes, so 1/4 plus 1/4 plus 1/4 plus 1/4. That means 1/4 plus 1/4. If we will add that 4 times, that is 1/4 into 4, because we are repeatedly adding 1/4 to 1/4 4 times. So we will get a 1 volt. If we will visualize that, so it will look like something like this. So 1/4 is this much. For getting the volt, we have to bring 4 parts. Yes, 4 1/4. We need 4 1/4. So after every year, this 0.25 becomes a day. Now you will say that it is gone already. So why does we keep it in the leap year? Let's have a look to that also. So now, here as we all know, it is a little complicated, isn't it? If someone will ask you how many days are in the year, so you will say 365 days only. What about this 0.25? It is also important. It carries also meaning, right? The exact is 365 days. And this 0.25 could be thought of as and 6 hours. And 6 hours. Now this 6 hours also carry the value, right? It is 6 hours. Now because of that, what happens is that we had decided to keep all the year normal, 365 days. All the year carries the 365 days. And then the fourth year, in the fourth year, we add an extra day to the February because here is the 6 hours, and when we plus 6 hours to 6 hours to 6 hours 4 times, when we plus the 6 hours 4 times, we will get 1 day. So that's because why we add, that's because that is how there are 366 days in the leap year, because this 6 hours also carry the value and that should be important, and because of that we add it to the fourth year, the leap year. Now I think this much is also clear to you, and now let's continue talking about the decimals. So firstly, let's talk about the importance of the placement of the decimal point. So, if I will have a decimal number, let's have 0.5 again. Now, let's have the 5 instead of this 0.5. So 5.0. So do you know that if I will just shift it to the right, just one place to the right, it will change the value. It will affect the value of the number a lot. We want to see, let's have a look. So 5.0, if I will just shift it out, here I will get 50. Now could you compare the 50 and the 5, who is bigger? 50. And do you know that the number has become 10 times of the 5. Yes, 50 is the 10 times of the 5. So because of that, as we know that it has affected a lot to the number, to the value of the number, isn't it? Could you see this out? 5 and 50. Now let's see if we will shift the number, we will shift the decimal point just one step to the left, what we will get? Let's see that. So if we will shift this decimal point to the left, we get 0.5. And now, where is the 5 and where is the 0.5? Can you thought of that also? It has changed the value much, right? As we can see that 0.5 is smaller than, even smaller than a 1. And the 5, you can thought of that, is bigger than the 1. You can see that there is a big change in the value when we place the decimal point to the left or to the right of the number. So the placement of the decimal point is very important, because it changed the whole value of the number. So I think, oh sorry, here I had written wrong. Yes. So now I think that this much is clear to you. And now let's move on to the place value chart, or the places. Let's talk about the places of the decimal numbers. Now, if we will have a number like, let's have 25.089. So let's have this one. So now let's make a table. Here as you can see, we now let's have an example, like as we had already taken 225.89. I had taken at that time 0, or you can take it now also, but just let's continue on this number. Let's continue in this example. Now the places are after the zero, after the point. This part is known as the decimal part, and this is the normal number part, the whole number part, and this is the fractional part, sorry, the decimal part here. Now let's see. So this, as we all know, the place values, yes, and the places of the whole numbers. Here is tens, here is ones, tens, 100,000, 10,000. Then it's continue on, and now I think that here is the decimal point. Now here you can thought of as the decimal. Now after the decimal point, here this part is the decimal part, and as we all know that it starts with the 10. So we will call this 8 as the 10th place. It is at the 10th place. It could be thought of as 1 upon 10. 1 upon 10. Or this is the 10th place value. And then here we have the 100th place value. Let me write it clearly. 100th place value. Now let's see, why does it start with the 10th? Why does not it start? Why it doesn't start with the 1th? Now let's see, why is that so? Now as we all know that the decimal, you can thought of the decimal as the fractions, right? We had already talked about that. Decimals could be written as 0.5. It carries the smallest number of decimal part, smallest number of decimal numbers here. Sorry, this, as you can see, the numbers after the decimal point is 5. So we can thought of as that 5, this much is the smallest, right? Not in the value. I'm not talking about the value. If we will talk about the value, then the 0.1 could be thought as the smallest. And there is so many more which could be the smallest. It could be 0.001, 0.00001. It could be more. Now, what I mean is that after the decimal point, the number of numbers, that means that after the decimal point, if we will look at the number here, it is only 1. Yes, the number of numbers here is only 1. So that means this is this much. Now if I want to represent it in the fractions, how I will do that? How we will do that? Very simple. Fraction like this, and it could be also thought of as like this. Now here can you see something very interesting, that this 10 is below the 5. The denominator is 10. Now here, as you can see that it is starting with a 10. We can call it as 5/10. Now if we will have the number like 5 upon 1, it doesn't carry any meaning, right? This 1 doesn't carry any meaning. It is just equivalent to the 5, the whole number. So because of that, the numbers, the places after the decimal point starts with the 10th, and then it goes on like as the 10th, 100, 1000, 10,000, lakh, 10 lakh, crore, 10 crores, and something like that. Now I think that this much is clear to you, and in my next video we are going to learn more about the decimals. And do why are there 366 days in a leap year. In my next video, we are also going to talk about so many interesting questions like this. So thank you for watching this video and have a cheerful day ahead. If you want any improvement in me, so you can comment it in the comment box.